So see guys, what is VTP pruning? Let's say 20.2 want to communicate with 20.1. Both are in same VLAN. Both are in same VLAN. So first 20.2 need MAC address of 20.1. So PC4 will generate what? ARP, and ARP is a broadcast. So whenever this PC will generate a frame, broadcast frame, and PC4 will forward that broadcast frame to switch number 2, and switch number 2 is going to forward one copy of that broadcast frame from this interface and one copy from this interface, right? Both link are trunk. This is trunk link, this is also trunk link. So switch 2 will forward one copy of broadcast to switch number 3 and one copy of that broadcast frame to switch number 1. Am I right?
Yes.
Okay, but switch 2 should not forward broadcast traffic of VLAN 20 to switch number 3 because we don't have any user in VLAN 20 here on switch number 3. Yes or no? On switch number 3 we don't have any user in VLAN 20. Then why switch 2 is sending broadcast message of VLAN 20 to switch number 3? Now if you want to avoid it, like my requirement is switch 2 should not forward broadcast message of VLAN 20 to switch number 3. How you can achieve it? How you will configure the scenario? Or let's say 30.2 want to communicate with let's say 40.1, right? So again this PC will generate broadcast message and switch 3 will forward broadcast message of VLAN 30 to switch number 2. On switch number 2 we don't have any user in VLAN 20, in VLAN 30. So again switch 3 should not forward broadcast message of VLAN 30 to switch number 2. So how you will achieve this scenario? Tell me, because we already discussed this.
We have to configure the VLAN on
We have to
that
remove,
particular interface. No,
yes,
actually, no need to configure as a trunk.
this link is trunk. So here on trunk link, actually on this trunk link, I have to remove VLAN 20 and VLAN 10, right? VLAN 20 and VLAN 10. So that switch 2 will never forward traffic of VLAN 20 and 10 from this interface, right? So I can remove VLAN 20 and VLAN 10 from this particular trunk interface. In the same way, on switch number 1, we don't have any user in VLAN 30 and 40. So on switch number 2, E0/0, we need to remove VLAN 30 and 40. So that switch 2 should not forward broadcast message of VLAN 30 and 40 to switch 1. Yes or no? Switch 2 should not forward broadcast message of VLAN 30 to switch number 1. So again here you have to remove VLAN 30 and 40 from this trunk link. Here you have to remove VLAN 10 and 20 on this link. On this link, again we have to remove VLAN 30 and VLAN 40 because switch 3 should not forward traffic of VLAN 30 and 40 to this interface. But this interface is connected with switch number 2 and switch number 1, and on switch 1 and 2 we don't have any user in VLAN 30 and 40. Yes or no, guys? So manually from all trunk ports you have to remove some VLANs, right? So here we have only less number of VLAN. Let's say on each switches we have 10 number of VLAN, right? Here we have VLAN 1 to 10, here we have VLAN 20 to 30, here we have VLAN let's say 40 to 50. So in this scenario I need to remove some VLAN from all trunk interfaces, right, manually. This is a static method. So there is no any problem, guys, but in a static you have to run lots of command on all switches. You can achieve same task with the help of VTP pruning, right? If you will enable VTP pruning on, let's say switch number 1, here I have enabled VTP pruning. So switch 1 is going to send one message to switch 2, and in that message switch 1 will inform to switch 2 that brother, I have user in VLAN 10 and VLAN 20 only, right? So automatically switch 2 will allow only these two VLAN in forwarding state. only these two VLAN will be in forwarding state on this interface. In the same way, switch 2 will also send message, that is join message of VTP, right? Switch 2 will also send join message to switch number 3 and switch number 1, that I have user in VLAN 10 and 20 only. So on switch 1 will receive VTP join message from switch 2. Switch 1 will allow only VLAN 10 and 20 on this interface in forwarding state. Getting my point? So
If 10.1 wants to communicate with 30.1,
okay, 10.1 want to communicate with 30.1, they
30.2,
can
30.
communicate.
Hmm.
They can communicate now, because we have inter VLAN routing. On router we have configure router on a stick, so they can communicate. But when let's say 10.1 is generating a broadcast message, right? So switch 1 should forward that broadcast message from this interface, right? So on this interface VLAN 10 should be in forwarding state. On this interface also VLAN 30 should be in forwarding state. On this interface also VLAN 10 should be in forwarding state, right?
If we configure pruning, then it won't allow, right? The VLAN 30 on that interface. That
No, this, see, if this switch want to reach to a user in VLAN 30, right? So on this interface we have to allow VLAN 30. This switch will send join message to switch number 2, that allow VLAN 10 and 20 only on this trunk link. Okay. Switch 3 will send VTP join message to switch number 2. Allow only VLAN 30 and 40 on this interface. Again switch 2 is going to forward that message to switch number 1. So switch 1 will also allow VLAN 30, VLAN 40, VLAN 10 and VLAN 20. So only these VLAN should be allowed on this interface. So either I can allow these VLAN with the help of manual configuration by using command allowed VLAN, or I can use what VTP pruning, or I can configure VTP pruning. Clear? So VTP pruning is used to remove some VLAN from the trunk link dynamically, automatically, you can say. Getting my point, guys? By default on the trunk link all VLANs are allowed. So if 30.2 want to communicate with 10.1, or any user, let's say this user 20.2 want to communicate with 20.1, right? So on this interface E0/1 VLAN 20 should be not in forwarding state. Otherwise switch 2 will forward one copy of broadcast message from this interface also, and then switch 3 will discard it. So unnecessary we are using bandwidth of this link, right? Switch number 3 is processing the broadcast packet, because when switch 3 will receive it, first it will check what tag number on the trunk link it is receiving frame, right? So tag number will be what, VLAN 10 or VLAN 20. So there is no any user in VLAN 10 and 20. Switch 3 will discard that frame. But if switch 3 is discarding, it will be better if switch 2 will not forward that broadcast frame to switch number 3. Okay, so let me show you configuration part also here. I have access of all switches. You can see switch 1. On switch 1, let me verify the configuration first. So interface trunk. So we don't have any trunk link here. Okay, I will configure the scenario. Config T interface E0/1 switch port access VLAN 10 exit interface E0/2 switch port access VLAN 20 and interface E0/0 switch port trunk encapsulation dot 1q and say switch port mode trunk, right? So now interface trunk. So you can see on E0/0 all VLAN are allowed. So if any user will generate broadcast message, switch 1 will forward that broadcast message to switch number 2, but switch 1 should forward broadcast message of VLAN 10, 20, 30, 40 only, right, from this interface from E0/0. On this interface E0/0 VLAN 10, 20, 30, 40 should be allowed. Switch 1 should not forward broadcast message of any other VLAN from this interface. Getting my point? And guys, we can enable VTP pruning only on server mode switch. So if you will enable VTP pruning on server mode switch, automatically client mode switches will on that feature. So for now you can see VLAN in a spanning tree forwarding state and not pruned. We don't have any interfaces over here now. Now only you can see VLAN 1 is in forwarding state. Right, and so VTP status, this switch is server, domain name is CCNA. In the same way, let me take you to switch number 2 and let me configure switch 2 also. Config T interface E0/0. Let me use range command, range E0/0 and E0/1 switch port trunk encapsulation dot 1q and switch port mode trunk. Then interface E0/2 switch port access VLAN 10 exit interface E0/3 here switch port access VLAN 20. So VLAN brief and so spanning tree, sorry, so interface trunk. So on this trunk interface VLAN 1, VLAN 10 and VLAN 20 is in forwarding state. Now you can see, check switch 1 trunk interface. Here also you can see VLAN 1, 10 and 20 are in forwarding state, right? On switch number 3 also, let me configure switch 3. Interface E0/0 switch port trunk encapsulation dot 1q and switch port mode trunk exit interface E0/2 switch port access VLAN 30 exit interface E0/1 switch port access VLAN, let's say 40. So VLAN brief. For 0/3 is
Can you check the VTP mode? In client, we can't add VLANs, right?
So it will, here on switch number 3, on switch number 1, I have to create VLAN, right? On server mode switch.
Yes, yes.
VLAN 30, VLAN 40, VLAN 10 and 20 is already there. Fine. Now here we have VLAN 30 and 40. And see guys, on switch number 1, by default VTP pruning is enable, but on real devices by default VTP pruning will be disabled. Here let me say VTP okay. So see on 0/1 interface VLAN 1, VLAN 10, 20, 30, 40 all are in forwarding state, but on this interface VLAN 30 and 40 should be in forwarding state only, right? VLAN 10 and 20 should not be in forwarding state, so that whenever user from VLAN 10 or 20 will generate broadcast message, switch 2 will not forward it to switch number 3, right? Hello, 1 minute. Okay, so I have captured the link and now I am going to enable VTP pruning here. Say VTP pruning. Just you need to run this command only. And after running this command, here we should have one VTP join message. See VTP join message. Who is sending this message? You can check Ethernet error source MAC. This is MAC address of switch 1. So spanning tree. This is MAC address of switch 1, right? Switch 1 have sent this join message. And if you will open this message, you can see it is sending information of VLAN. It's saying I have user in this VLAN only, VLAN 10, 20 and 1. So on switch 2 will receive this VTP join message. On switch 2 will receive this VTP message. Now you can check show interface trunk command here. Earlier on 0/0 all VLAN was allowed, and on 0/1 also all VLAN was in forwarding state. But now if you will run show interface trunk command, you can see on 0/0 interface VLAN 1, 10, 20 only these 3 VLANs are in forwarding state. On 0/1 VLAN 1, 30 and 40 are in forwarding state. So now switch 2 is not going to forward any broadcast message of VLAN 20 and 10 from this interface, right? Because on this interface only these VLAN are in forwarding state. In the same way on switch number 3, so interface trunk. So you can see on this interface VLAN 30 and VLAN 40s are not allowed, not in forwarding state. So this is why we come up with VTP pruning. Is it clear guys to everyone?
Yeah, it's clear, Prabhu. Thank you.
Okay, so now I am moving to next topic, that is port security. Port
Sir, will VTP pruning works in transparent mode?
VTP pruning, no, VTP pruning will not work on transparent mode. Actually, on transparent mode, as I told you, transparent mode is like, we are telling to switch to not update your VLAN database with the help of VTP messages, right? So transparent mode switch only relay VTP messages. Let's say this switch is my transparent mode, switch number 2. So whenever switch 2 will receive any message of VTP on this interface, it will only relay that VTP message from this interface, right? It is not going to check any information inside VTP message. So it will not work on transparent mode switch. And on VTP on client mode switch, you can even not configure VTP pruning. If I will try to configure VTP pruning on switch number 2, VTP pruning. So you can see can't modify pruning unless in VTP server mode, right? But on server mode we have enabled VTP pruning. So on this switch, so VTP status, here also you can see VTP pruning is enabled. So client mode switches will enable VTP pruning automatically. It will negotiate from the server mode, right? Once it will client mode switch will receive join message, it will enable VTP pruning. And how it's working? All switches are sending, VTP join message to their neighbor, and in that join message it is sharing active VLAN, right? Active user in VLAN, sorry, VLANs which are in active state, means user are present in VLANs. Like on switch number 1 we have user in VLAN 10 and 20, so it will send information of VLAN 10 20 to switch number 2. So switch number 2 will allow only those two VLAN on this interface. So reason of VTP pruning is, we can say, to reduce a non-unicast flooding, right? To reduce broadcast, broadcast flooding. Otherwise, by default, on trunk link, all VLANs are allowed and all VLANs are in forwarding state. Fine. Now, what is port security? Guys, these are very small topics like VTP pruning, port security, switch port protect. These are small topics. What we call it, switch port security. This feature is used to bind MAC address with switch interface. Used to bind MAC address with port, with interfaces of switch. This feature offer to bind MAC addresses with, or we can say, to use to limit the traffic on switch interface, on switch port. Let's say I have one switch here like this. I have one switch here. On this switch we have some ports. Switch 1, 0/1, 0/2, 0/3, 0/4 and 0/5, let's say, right? Now on these ports, any user can connect their computers or their server, any devices, right? You can connect any device to any interface. This is 0/1, this is 0/2, 0/3, 0/4 and 0/5. But my requirement is what? I want to allow only those computer on 0/1 interface whose MAC address is A. Let's say there is one computer whose MAC address is A. So I want to allow only those computer, only that computer whose MAC address is A on 0/1 interface, right? Or we can allow multiple MAC addresses also on single interface. So let's say on this interface we have allowed only device whose MAC address is A, B and C. A, B and C, right? So either we can connect device whose MAC address is A with this interface, or MAC address is B, or MAC address is C. If you will connect any other computer except these MAC addresses, switch will put that interface in error disable state. Switch will put this interface in error disable state. So with the help of port security, we can allow a specific user on a specific interface. We can limit the user. Like let's say in my company there are 5 engineers, right? 5 engineers are working: computer A, computer B, C, D, and let's say E. These are my employee. So I will allow these MAC addresses on all interfaces, right? I will allow only these MAC addresses on all interfaces of this switch. So only my employees can connect their computer with this switch, right? Except my employee. If someone else will come, or let's say if you will try to connect your own laptop, right? Let's say company have provided you one laptop and company have configured their MAC address on their interfaces, on their switch interfaces, right? And if you want to download some movie in your let's say laptop, so what you will do, you will connect your laptop with an interface and then you will try to access internet, but your MAC address is not allowed on any interfaces of switch, so switch will put that interface in error disable mode. Clear, guys? So in this scenario you can see on switch number 1, so MAC address, so MAC address table. So this switch have one MAC address on E0/0 interface, two MAC address on 0/0 interface. If PC1 will generate any frame, let me configure one IP here 10.1.1.1/24, right? So it will generate hsrp. Now switch 1 will learn MAC address of PC1 on 0/1 interface, right? This is MAC address of PC1. But now I can remove this PC and I can connect another PC as well here, right? But if you will bind this my MAC address with this interface, then you cannot connect any other computer on 0/1 interface. You cannot connect any other computer on 0/1 interface. Clear, guys? Theory part. It is used to bind MAC address of end devices with interface. So configuration is very simple. On switch interface E0/1, here you will run command switch port. Port security, this command will enable port security feature over here. So this port is not access, switch port mode access, and then say switch port security, right? After that switch port security maximum means how many MAC addresses you want to allow on this interface. Let's say I want to allow only single MAC address here, maximum 1. Then switch port, and you can see how many MAC addresses you can configure on this interface. 4097. You can allow 4097 MAC addresses on a single interface, but now I am allowing only one MAC address, right? After that switch port security, and violation. Violation means, guys, this is action. Like if this switch will receive any frame with different MAC address, then what switch will do?
Why we have only that 4097 here?
Here.
Yes, that range. Hello?
Yes. This range.
Yes.
We can allow around 4000 MAC addresses on a single interface.
No, why?
Why we have this range?
Yeah, actually I got this question in interview.
Okay. Because of VLAN, I think.
Okay. VLANs.
Correct.
VLAN also we have that 4096, right?
Correct.
Why?
Wait,
Why
wait.
we don't have that 4098 or 97? Actually, I googled it that actually that one. Okay, I got that answer after after that interview
Okay. So what is the answer?
because we have that 12 bit na. So 2 raised to 12 means that is 4096.
Mm-hmm.
So we have to create only that 4096 VLANs only. So that's why we have that 40. If we do the 2 raised to 12, okay, because our
Yeah.
MAC address is 12 bit only na, 12 bits.
Okay.
We are representing like 12 bits.
MAC address is 6 byte information, 48 bits.
Yeah, 48 bits, but we are representing uh, in that hexadecimal 12, 12 places, right? In hex form. So if we do that 2 raised to 12 means that range will be 4096.
Mm-hmm.
So that's the reason we are able to configure only that 4096 VLANs and this one maximum 4096.
Okay. Okay, we will discuss on this again later. Leave it for now. See, now violation, we have three violation. Violation means action. That switch will take what action if it will receive any frame with different MAC address. With different MAC address. So either we can configure violation protection, we can protect, we can configure restrict, and we can configure shutdown. Shutdown and protect is same. Shutdown and protect both are same, but again you can see there are some difference in both. Shutdown means this is default action, default violation. So when any unauthorized take place, then port will move into error disable state. Also provide a log of MAC address created, means it will create one log message that from this MAC address a user is trying to connect. After violation, authorized user will also not able to communicate. So you have to run shutdown command and no shutdown command to recover the port. So once port will enter in error disable mode, you have to run shutdown command then no shutdown command. Then protect. It will only block the traffic of unauthorized user, right? If any unauthorized user will try to connect their computer, right, switches will drop the traffic. Switches will drop the traffic if we will configure this violation protection, but the traffic of authorized user will continue to transmit. Means again if authorized user will connect their computer so they can communicate, because protect mode will not put interface in error disable mode. So port will be still in forwarding state, but it will not allow unauthorized user only. It will discard the packet. Then we have third mode, restrict. Same like protect and log message to SN. So if we have in real time we will have one server, SNMP server for log message. On this server we will store all log message of devices, and after that with the help of log message we can analyze the devices, we can monitor the devices. Okay, and then you have command like this. So here let's say let me set violation shutdown over here for now. Okay, now what will happen if I will connect any other computer with this interface? Let's say I have one another computer here, virtual PC, this one, and I'm going to save the configuration of switch 1 because I will down it this switch, and let me off it. Okay, again I am going to up this switch and see when I will configure IP address on this PC, it will generate hsrp. It will generate gracious ARP on switch number 1. So run interface E0/1. So this is configuration, and here we need to define MAC address as well, like which MAC address you want to allow on this interface. So let me do that also. Here interface E0/1 switch port security MAC address, and here I am going to copy MAC address of PC1 MAC address. So IP all. Okay, now so run interface E0/1. Right, this is port security configuration. Now on this PC, let me configure one IP here. IP, let's say 10.1.1.100/24. It will generate GRP, and now on switch number 1, you can see interface E0/1, change state to down. Here we are able to see log message as well. Security violation occur caused by MAC address. This one is MAC address of new PC on port 0/1, Ethernet 0/1, and this port is in error disable. So interface status error disable. You can see this port is in error disable because of port security violation. Because of port security violation. Clear? Now again I am going to connect PC1. Right? Now to recover 0/1 interface on switch 1, you have to run shutdown command and no shut command. Right? So go to again interface 0/1, interface E0/1, say shutdown, and then say no shutdown. So interface status error disable. Now we don't have any interface in error disable mode, right? And so interface status E0/1 is connected in VLAN 10. Right? Again on PC number 1, I am going to configure IP address. IP 10.1.1.1/24, let's say. But this time you can see switch will allow this user, right? So MAC address table. Now switch is learning MAC address on 0/1 interface. So on this interface, only this MAC address is allowed. In the same way, you can bind multiple MAC address, and you can configure one more thing here, interface E0/1, or we can say switch port security MAC address sticky. Means it will bind MAC address from MAC address table. It will bind MAC address from MAC address table. It will check their MAC address table, and whatever MAC address is there in the MAC address table on this interface, right? Switch will automatically bind that MAC address with this interface. This is dynamic method. Either here we can define MAC address, or we can use this keyword ST key. right? So on all switches you need to run this command. On interface E0/2 also switch port, port security, switch port mode access, switch port security, switch port security maximum 1, then switch port security violation shutdown, and then switch port security MAC address sticky. On switch number
Praful,
mhm.
can we do the Mac clone?
What?
Mac clone.
MAC?
Clone. Cloning.
I'm not getting your question, brother. Mac, can you type in chat?
Yeah.
Yes, type it in chat. Here also switch port mode access first, then switch port security, then switch port security violation. Let's say here we can configure restrict, and then switch port security MAC address sticky, switch port security violation. And if you will not define violation, by default violation is shut down. Attacker can do the MAC done, MAC clone. What is command to configure MAC clone? Do you know command?
No, no, Prabhalji.
So it's saying MAC clone is also like, port security. So for port security, these are the command to enable. Clear? Any question, guys, in port security? Because now we are moving to next topic, that
Can-
is,
Sir, can we
yes.
do it in the trunk interface? The port security.
Can we?
Can we do it in the trunk interface?
No, you can configure it on access port.
Only on the access port.
Yes.
Okay.
Here you can see first I have to run this command. Switch port mode access. This is for access port.
Okay.
Any other question?
Can you explain that sticky again?
A sticky means, now you can see here on switch number 2 we have enabled port security on 0/0 and 0/2 and 0/3, but we have not defined MAC address, which MAC address I am going to bind on these interfaces. So this switch will check their MAC address table. So MAC address table, in their MAC address table, is there any MAC address on E0/2? No, right? So when switch 2 will receive any frame on 0/2, it will learn MAC address on 0/2 interface, and it will bind that MAC address in port security. It will bind that MAC address with the interface. So first MAC address which switch will learn on that interface will be binded with this interface. Static means defining MAC address from MAC address table.
Sticky is nothing but dynamic MAC getting.
Correct.
If you disconnect the device and connect another device, then what happens if you configure the interface as sticky?
Then switch will put that interface in error disable mode. Whatever action you have defined, right?
MAC table.
It will bind first MAC address, right? Whatever MAC address it will learn first on this interface, that will be banded on this interface.
Okay.
Okay, now guys, then we have a span in switching. A span is again a span is very clear with name. A span stands for switch port analyzer. Like you can see in this scenario on switch, in the console of switch, you cannot see which type of traffic coming on E0/1 interface, or which type of traffic is going from this interface. On switch console we cannot monitor it, right? On switch we cannot see PC1 is forwarding ICMP traffic from this interface, or which type of traffic switch this PC is receiving on this interface, or PC is forwarding on this interface. So we come up with a span feature. Through a span feature, what we can do, we can monitor the switch port. Let's say here I have scenario like this. I have one switch, and here I have one user, and this port is, let's say, 0/1. This is PC1. Okay, IP address of this PC 10.1.1.1/24. Gateway is, let's say, 10.1.1.100. Okay, this is my switch, and this switch is, let's say, connected with one router, and then router is connected with, let's say, internet. So here on switch console I cannot monitor this interface. Actually I want to know PC1 is forwarding which type of traffic, or let's say here we have on another PC also, PC2. I want to know PC1 is forwarding which type of traffic to PC2, right? So on a particular interface I can monitor incoming traffic, I can monitor outgoing traffic, and I can monitor both incoming as well as outgoing traffic. So let's say here I want to monitor this interface. So I will configure a span so that switch will forward one copy of each packet to a particular interface, from a particular interface. Let's say here we have network admin. This is computer of network admin 0/2, right? So what I want, whatever packet will hit on this interface, or whatever packet will out from this interface, this switch should forward one copy of that packet to this interface, right? So that my network admin will get one incoming packet, and whatever outgoing packet, they will get one packet here also, right? Let's say thousands of packet is PC1 is forwarding thousands of packets from this interface. So switch will forward one copy of 1000 packet to network admin computer also, like from this interface, from 0/2 interface. So how a span will work? Here in a span, we are going to tell to switch one, this interface is your source and this interface is your destination. And a span always send one copy of source, one copy of packet on source interface to destination interface, right? And we can tell that also that you should monitor inbound traffic, outbound traffic, or both. So I will define, let's say, both, and send me one copy of each packet from this interface. So this interface is going to be my destination port and this interface is going to be my source port, right? And there are two types of span. One is local span and another one is remote span. If source and destination both ports are present in a single switch, that is called local span. And let's say this switch is connected with another switch and my destination port is here, network admin is here. So if source port is on different switch and destination port is in different switch, right, that type of span is called remote span. Got it?
Come again, sir. Hello.
Yes, yes, you are audible.
Yeah, come again.
Sorry?
Local span means. Can you say again?
Source port and destination port both are present in single switch, on same switch,
Okay.
right? In remote, source port is on different switch and destination is on different switch,
Okay.
right? Maybe I have a scenario like this. Here switch, here I have one user, this switch is connected with one router and router is connected with ISP, ISP is connected with another router, and here I have network admin, right? I want to monitor this port, right? But destination is this port. So this time you can see source port is on different switch and destination port is on different switch. So in this scenario you will configure remote span, right? Or switch 1, switch 2, trunk. Here I have source, I want to monitor this port, but destination is here, right? Network admin is here. Again you can see destination is on another switch and source is on another switch. So in this scenario also we will configure remote span, right? But again, if I have scenario like this, see, on same switch I have source port and this is destination port, this is network admin, right? I want to monitor this port, so this is my source, this is my destination, so both are present in same switch. So this here we will configure local span. So a span is used to monitor switch port, it is used to monitor, and it is also called port mirroring, to analyze network traffic passing through switch port. Now configuration is very simple. See, configuration here, let's say PC1 IP address is 10.1.1.1, right? Let's say PC2 IP address is 10.1.1.2, 10.1.1.2/24, right? And let's say here we have one more PC, that is network admin PC. Let me connect one more PC here. Okay, now let me take you to switch 1. On switch 1, I want to monitor E0/1 interface, right? So this interface will be my source and E0/3 will be my destination. So here I can run this command. Monitor and then session. After that, session number. So range is 1 to 69. So let me use monitor session number 10. And then we can say source port. Source interface. Which interface is source? Ethernet 0/1. Then say monitor session. In same we are going to define destination. Destination interface E0/3. That's it. That's it. Now from PC1 here you can see one thing. So interface E0/1, and on this interface what we can see, we can say, let's say right. So we have 0 packet here. Let me check one more thing here. I am going to remove VLAN configuration. I am going to put these two interfaces in same VLAN so that PC1 can communicate with PC2. So interface E0/1, no switch port security, and switch port access VLAN 1. Interface E0/2, switch port access VLAN 1, no switch port security. Now let me check PC1 is able to ping PC2 or not. From PC1 I am going to ping 10.10.1.1.2. Sorry, what is the IP address of PC2? What happened? Ping 10.1.1.2, right? I am able to ping, and on switch 1 so interface output. I'm going to show you output packet on 0/3 interface. So here output packet is 0 and 0/1. So monitor session 10, source port is 0/1, destination port is 0/3 native. Okay, direction is both. local span. Let's forward packet from this interface. So interface status, so 0/3, this port is actually disabled. Let me run no set command here on this PC. Interface f0/0, say no set, and IP address 10.1.1. Let's say 100.255.255.255.0. Now again let me take you to switch 1 and show interface status. Soon this port will come up. Right, so now you can see this port is monitoring. So again I am going to ping PC2 from PC1. Fine. And now if you will check output packet on 0/3 interface, so you can see packet count is increasing. Packet count is increasing. That means switch 1 is forwarding one copy of ICMP packet from this interface also. Here can I use T? So see, it is continuously forwarding ICMP traffic. So on this interface you can see packet count is continuously increasing. So switch 1 is forwarding one copy of ICMP packet from this interface, from 0/3 interface, right? Clear? So span is used to monitor switch port. Now if you need to configure, let's say, remote span, so here I can say no monitor session 10. Now you can verify, so monitor session 10. Okay, so again I am going to configure span here, and this time let's say I want to forward one copy from this interface, from let's say 0/1 of switch 2. So this type of span is remote span, because this time my source is this interface, destination is this interface. Source is this interface, destination is this interface. So this type of span is remote span. So in remote span, to configure remote span, first of all you have to configure span VLAN, one VLAN for span. Let's say I am going to use VLAN 100 for span, right? So on switch 1 I will run command monitor session, again let's say number 10, and source interface Ethernet 0/1. Or we can monitor multiple interface also, like I want to monitor E0/1 to 0/2. So here I can say 0/1 to 2, like this also we can run command. And after that we can define direction as well, in which direction you want to monitor, receive traffic, transmit traffic, or both. So I can say both. If you will not define, by default it will take both, right? Then here I will configure VLAN 100, and I can say span remote span, right? This is configuration of switch 1. So VLAN remote span. So you can see VLAN 100 is remote span. Now monitor session. In CCNA you need to learn only local span, but see remote span also. Here we can say remote monitor session group number 10, and then source remote VLAN 100. Can't add remote span VLAN as source for span session 10, as it is not a remote span destination. Actually remote span 10 is already there, right? So what I can do, I can configure any other number. Let's say monitor session 20 source interface E0/122 and both VLAN 100 remote span exit monitor session group number 20 destination remote VLAN 100. VLAN 100, then again on this is configuration of switch 1, and then let me take you to switch 2, and on switch number 2 you will run this command monitor session number should be same 20, and then we are going to say source remote VLAN 100, and then monitor session number 20 destination interface E1/0. This is remote span configuration, right? Now in this scenario we are monitoring these two interfaces, right? So whatever traffic will enter on these two interfaces, or whatever traffic will out from these two interfaces, switch 1 will forward one copy to this interface through VLAN 100. Because on trunk link, why we have configured VLAN 100 for span? So that whenever switch will carry traffic of span, it will add tag number 100 on trunk link. It will add tag number 100 on the trunk link, and whenever switch 2 will receive traffic, right, it will check tag what 100, and tag 100 is for remote span. Switch 2 will came to know that this is of traffic of monitoring, so it will hand over to destination port, which is 1/0. This is configuration of remote span. Clear? So interface trunk, you can see on this interface now VLAN 100 is in forwarding state, right? So here I can access switch 2, and on switch 2 what command I can run? So interface, again I think interface 0/1 is down, so interface status is 0/1 connected 0/1. Here I have to run no such command on router. Now last topic of switching is first hop redundancy protocol, FHRP. See, okay. Clear, guys? So span is used to monitor switch port. Port security is used to bind MAC addresses, or you can say limit users on switch port. Then we have which topic? FHRP, first hop redundancy protocol. Okay, so let's say, guys, here I have one switch, and then I have some user here, PC1, PC2, PC3. And this switch is connected with one router, and let's say this router is connected with ISP. So in this scenario, we don't have any redundancy for default gateway, right? We don't have any redundancy for default gateway. Let's say your IP address is 1.1.1. IP address of computer 2 is 1.2. This computer IP address is 1. Let's say 3, and this computer IP address is, let's say, 1.4. So on this all computer, you will define default gateway what? 1.1.1. For this all machine, default gateway will be 1.1.1. But if default gateway will goes down, right, then this user cannot access internet, because here we don't have any redundant path to reach ISP, right? So this is good design for home or for small offices, but this is not good design for 100% reliability. If you need 100% reliability, like internet should be available 24/7 in your office, then you should have purchase one more connection from ISP. You should have one more default gateway. So then what will you do? Again, you will purchase one switch. Here you will connect end devices, computers, and this time I am going to use 2 router for default gateway. Two router, R1 and R2. And let's say routers are connected with, again, ISP, with same ISP or with different ISP. So if you have two connectivity, definitely you will take connectivity from two different ISP. Otherwise, what will happen if ISP will goes down? So let's say router 1 is connected with different ISP, and router 2 is connected with different ISP, right? And router 1 is connected with switch, router 2 is also connected with switch. Here we have computers.
Can we configure two ISPs to one router?
Yes. Here IP address is, let's say, 10.1.1.10.1.1.1. Here IP address is 10.1.1.2. So guys, on these computers, what will be default gateway? Default gateway can be 10.1.1.1 or it can be 10.1.1.2. Yes or no? If I will define default gateway 10.1.1.1, right, these all user will access internet through router 1. If I will define default gateway 10.1.1.2, all user will access internet through router number 2. And let's say here on these computers, here we have, let's say, one DHCP server, right, who is responsible to provide IP addresses to computers, right? So this DHCP server is going to, let's say, provide default gateway what? 10.1.1.1, right? So these all user will get default gateway what? 10.1.1.1, right? So when router 1 will goes down, manually you have to change default gateway on all routers. Yes or no? Manually you have to change default gateway IP address on all computers. You have to set now default gateway 10.1.1.2. right? So that's why we come up with FHRP protocol. With the help of FHRP protocol, what I can do, with the help of these two physical IP address, I can create one virtual IP address, right? I can create one virtual IP address. Let's say that is my 10 dot, that is my 10.1.1.100. This is my virtual IP address, and I will define this IP address as default gateway to these user. For these all user, I will assign this IP address as default gateway. Now default gateway is virtual IP address 10.1.1.100, and here we will run FHRP protocol. We have three protocols here, right? We can run any one. Working of all protocols is exactly same purpose is same, right? Providing redundancy for default gateway for first hop. So with the help of FHRP protocol, these two routers are going to exchange some hello messages, and then this router will decide which router will become active, which router will become standby, which router will become active, which router will become standby. One router will become active, another router will become standby. So let's say R1 is my active router, R2 is standby router, right? So now let's say this PC IP address is 10.1.1.5, right? Default gateway is 10.1.1.100. Now if this PC want to access 8.8.8.8, this PC need MAC address of their default gateway, so it will generate one ARP request message for 10.1.1.100. And which router will generate reply message of ARP? Active router, right? Active router will share their MAC address. In the same way, all these user will get MAC address of router 1. So destination MAC will be the MAC address of router 1 in the packet for all devices. Okay, and switch will have switch will learn MAC address of router 1 on this interface, right? So switch will forward traffic towards router number 1. But again, when router 1 will goes down, right, here we are running protocol, so once router 1 will get down, then router 2 will not receive any message from router number 1. So router 2 will declare their self as active, and after that router 2 will start sharing their MAC address for this IP address, right? So until active router will be up, right, default gateway will be R1. If active router will goes down, R2 will become active. This is the concept of FHRP, first hop redundancy protocol. Now we have three types of protocol. First one is hsrp, then vrrp, then glbp, right? And here we can achieve load balancing as well. Let's say these two users are in VLAN 10 and these two users are in VLAN 20. What I want, for VLAN 10 user R1 should be my active, and for VLAN 20 user R2 should be my active, right? And R1 should be standby for VLAN 20, R2 should be standby for VLAN 10. But if any router will goes down, one router will become active for both VLAN. Clear guys, the logic of FHRP protocol?
Can we do it practically
Yes,
now?
we will do. Yeah, we will do practically also, and we will discuss each protocols as well. This is basic logic behind FHRP protocol. So we come up with FHRP protocol for redundancy of default gateway.
If the interface connected to if the router interface connected to the internet goes down, what happens?
This interface.
Yes.
So here you will configure IP SLA to track ISP1. In hsrp, track is inbuilt. You can track ISP1 as well. Like until ISP1 is up, router 1 will continuously tracking ISP1. If track is up, then router 1 will be active. If track wheel goes down, then automatically router 2 will become active. So those features we have in protocols, or we can configure a, external track as well. Fine. So first protocol is hsrp. hsrp stands for
Recording is on, right, sir?
yes,
Okay.
hot standby router protocol. Hot standby router protocol. It is an Cisco proprietary protocol. That means we can run this protocol only on Cisco devices. Okay. Hello timer over here is 3 seconds. Means after 3 seconds, both router will send hello message to their neighbor. Right. And if I will talk about hold on time, so hold on time is 10 seconds. 10 seconds. Right. We can change this timer as well. This protocol work on UDP. UDP port number 1985, I think. Yes, 1985. After that, it send their messages on multicast address 224 dot multicast address 224.0.0.2. Right. Now question is which router will become active and which router will become standby. For that again we have priority on router. And if I will talk about by default priority is 100. Right. And as I told you, track is in build. Track is inbuilt. That means we can track ISP. Right. We will discuss about this point also, but just I am writing one more point here, and we will talk about this later. Like whenever track wheel goes down, it will decrement priority by 10. If we are using track, so if track wheel goes down, it will decrement priority by 1, and higher priority is best. So router who will have higher priority will become active router, and if track wheel goes down, it will decrement priority by 1. So if here on the router priority will become what 90, so automatically other router will become what active. So it decrement priority by 10 by default. Right.
Praful, this option is not available in vrrp, I mean track and build.
In vrrp, no, there you have to use external track. In build is not there.
Okay.
In hsrp we have inbuilt feature. If I will talk about guys virtual MAC address, like we are creating virtual IP address with the help of multiple physical IP address. So how routers are going to create virtual MAC address? So virtual MAC address for hsrp will be always this one, virtual MAC address 000.060.0607, I think, and then AC, and after that group number like XX, let's say.
No, what is the use for this virtual MAC? Because even here I'm using vrrp. In vrrp also we are using virtual IP address, right? So there we are using
For that
virtual IP.
virtual IP address, user need what? One MAC address, na?
Okay.
Right? So active router will share this MAC address.
Now my question is, in vrrp we are using virtual IP. In hsrp we will be using virtual MAC. How it will be?
Virtual IP. Here also we are using virtual IP. In vrrp also we are using virtual IP. For virtual IP address, host switches is going to create virtual MAC address. So virtual MAC address will be always this, right? In last two value will be group number. So let's say I am creating, group number 10 for hsrp. So here value will be 10 in hexadecimal.
Yeah, got it. Thank you.
Right? So it is going to use last two values for virtual MAC address. This is how router will create virtual MAC address. The maximum group that we can create in hsrp is maximum group we can create 0 to 255. We can create up to 255 group. And by default preemption is disable. We will talk about preemption also. Preemption is disabled by default, right? So these are, guys, basic points about hsrp. We will discuss all points while configuring, right? After that, if I will talk about states in hsrp. So we have disable state. Again, disable state is like shutdown. Then we have a speaking state. Then we have listening state. Then we have a standby state. And after that we have active state. For one group, only one router will be active. Let's say we have, multiple number of default gateway. So if you have configured only one group, right, you have configured all routers in one group. So for one group, you will have only one active router, and all other router will be in standby mode, right? All routers will be in standby mode. One router will be in active, one router will be in standby, and all other router will be in listening state. All other router will be in listening state. Now which router will be in active? Router who will have highest priority. If priority is same, then router who will have highest IP address. Let's say I have three router here, R1, R2, R3. By default priority on all router is 100, 100, 100, 100 in hsrp, right? Let's say here IP address is 192.168.1.1. Here IP address is 192.168.1.2. Here IP address is 192.168.1.3. So which router will become active in this scenario? R3. R3 will become active because R3 have highest IP address. Right?
We can able to define manually, right?
Yes, manually we will define. We will manually configure the IP address. Now this is by default priority on routers, that is 100. And manually we will define IP addresses. Like this. Right. So guys, but again, if you will configure hsrp on router 1 first, right? And you will wait for 10 seconds, right? After 10 seconds, if you will configure hsrp on these router, then router 1 will become active. Same like DR and BDR in OSPF. For DR and BDR, router will wait for 40 seconds. If within 40 seconds router will not receive any hello message with higher priority or higher router ID, that router will declare their self as dr. In the same way, in hsrp, first let's say I have configured hsrp on router number 1, so it will wait for 10 seconds. Within 10 seconds it will receive hello message from any router with higher priority or higher IP address. Then only it will declare their self as a standby or in listening state. Otherwise, router 1 will declare their self as active. And once one router will become active in the group, right? Not other router can become active. Then these router will be in a standby. One router will be in a standby and one router will be in listening state. So R3 will be in standby mode and R2 will be in listening state.
Okay, if I want R1 will be master, then I can able to increase the
Here you can
priority, right?
increase the priority. Yes.
Yeah. Okay.
Here you can set priority, let's say 101, 110. So R1 will always become active.
Got it. Thank you.
Right. So in this scenario, let's say I have configured hsrp on these all router at the same time. Then router 3 will become what? Active. This router will become active. Router 2 will be in standby. Standby means when active will goes down, router 2 will become active. And this router is in will be in listening state. In listening state. Fine. So if router 1 will goes down, router 2 will become active and router 1 will come in standby. Router 1 will become standby. Now if I will talk about message, hello message of hsrp. So let's say on router number 1 I have enabled hsrp, right? So it will encapsulate one hello packet of hsrp at which layer? At application layer, right? In the hello message, priority will be what? 100 and IP address will be what? 192.168.1.1, my IP address. So in the hello message it will share both information, priority and IP address. Then only other routers can compare which router should become active, right? After that, at layer 4, source port will be any random port number and destination port will be what? 1985 port number, which is reserved for hsrp. Then at layer 3, source IP will be what? 192.168.1.1 and destination IP will be 224.0.0.2 multicast address. Then at layer 2, source MAC will be MAC address of exit interface and destination MAC will be again multicast, right? This is hello message of hsrp, right? So all routers will encapsulate their hello messages and it will exchange with their neighbor. So all router will get to know which router have higher priority or higher IP address. That router will become what? Active. Okay. So tomorrow we will perform lab of hsrp protocol. Lab of hsrp protocol. And guys, preemption means what? By default, see, preemption is disabled. By default, preemption is disabled. That's why if you will configure hsrp on router 1 first, router 1 will become active. If you will enable preemption, right? If you will enable preemption, then whenever a new router will come in hsrp group, right? If that router have higher priority or higher IP address, that router will become active. That router will become active. Preemption means what? It will allow router who have highest priority or highest IP address can become active even if active router is present in the group. If preemption is disabled, then if active router is present in the group and any router is coming up with higher priority or higher IP address, that router will not become active, right?
Come again, Jay. Sorry. How it will?
Preemption means let's say preemption is by default disabled, right? So R3 is my active router, right? Here I want 1 should be my active. So here I am going to configure priority 110. Now R1 should become active, yes or no, because R1 have highest priority. But if active router is present in the group, then no one can replace active router until and unless active router will goes down. Right? If active router will goes down, then maybe R1 will become active router, and definitely R1 will become active router. But until and unless active router is up, and even router have highest priority, that will not become active. But if you will enable preemption, right, it is going to negotiate active, and standby election will happen every time whenever a new router will come in the group. But if preemption is disabled and new routers will come up in group, right, active and standby election will not happen again until and unless active router is present. Got it?
Okay, okay.
So if you will enable preemption, and then if you will change priority on any router, that router will become active. If preemption is disabled, like by default it is disabled, so if you will configure hsrp on router number 1 first, then router 1 will become what? Active. Then you will configure hsrp on router number 2, this router will become a standby. Then you will configure hsrp on router number 3, this router will become what? Listening. It will be in listening state, right? But again, preemption for standby and listening is enabled, but preemption for active router is disabled. So these, out of these two router, which router will become a standby? This router. This router will become a standby, and this router will be in listening state, right? But if preemption is enabled for active also, then R3 should become active, right? Because R3 have highest priority, sorry, IP address. So by default, preemption is enabled for standby and listening, but preemption is disabled for active and standby. Got it, guys?
Okay. If suppose if we disable that preemption in that R1, if suppose that R1 is goes down means election will be happen between R2 and R3 only, right? Uh,
Correct. Correct.
okay.
So
Actually, how it will come to know this link is goes down? If
which link?
like if suppose
If router
R1,
2 will not receive any hello message from router number 1, it will came to know na. Now I am not receiving any hello message from router number 1. That means my active router is down. Now router 2 is receiving hello message from router number 3. So it will compare priority and IP address. So if R1 will goes down, R2 will become what? Standby, and R3 will become what? Active. And active router will respond to ARP, right? So whenever LAN user will generate ARP for their default gateway, because here on this PC we will define virtual default gateway. Let's say my virtual default gateway is 192.168.1.100, right? So this IP address will be default gateway for this user. So this user will generate ARP for this IP address, and active router will respond. Active router will respond, and switch will learn MAC address of this virtual IP address on this interface. Let's say if router 3 is active router, because only R3 is going to respond. And in hsrp, let's say we have configured group number 10. So what will be virtual MAC address? In last 10. We can configure up to 255 groups. If I will talk about vrrp, so vrrp is open standard protocol. In vrrp, hello time is 1 second, means after 1 second it will send hello message. Hold on time is 3 seconds, right? And hsrp is an application layer protocol, vrrp is layer 3 protocol. So vrrp protocol will use protocol number, right? Because it is a layer 3 protocol. So protocol number of vrrp protocol is 112. like protocol number of EIGRP, OSPF, right? VRRP uses multicast address 224.0.0.18. And in VRRP, preemption is by default enabled. By default, preemption is enabled. In VRRP, one router will become master and one router will become what? Slab. Master router will be in active state and slab router will be in standby state. After election of master, only master router will send hello message in VRRP. But in hsrp, this router is my active router, this is a standby, this is let's say listening, right? But again, standby router will also send hello message, this router will also send hello message, this router will also send hello message. So this is difference between VRRP and hsrp. Election criteria of master router is exactly same in VRRP like hsrp. First it will check what? Priority, highest priority is the best, and then it will check what? Highest IP address. And there also by default priority is 100 in VRRP also, right? In VRRP also by default priority is 1, right? Configuration will be also, most of the configuration will be same in VRRP, hsrp. But here in VRRP, if you want to track ISP, as I told you, let's say these all routers are connected with ISP or with different ISP, right? So if you want to track ISP, then here you have to use external track. You have to create one external track in VRRP, because in VRRP we don't have track feature, but in hsrp we have track feature. Then we have glbp protocol. See, in VRRP and in hsrp we have one problem: we cannot achieve load balancing. Again, we can achieve load balancing by creating multiple group, but in single group we cannot achieve load balancing. For load balancing you have to create multiple group. If you will create multiple group, router will send multiple hello messages, right? Router will send multiple hello messages. So to reduce CPU utilization, you will use this protocol glbp, because in glbp we can achieve load balancing in same group. So this is the biggest advantage of glbp protocol, and this is the reason why we are using this protocol nowadays, right? glbp stand for, vrrp stand for what? vrrp stand for virtual router redundancy protocol, and glbp stand for gateway load balancing protocol. Gateway load balancing protocol. glbp is mainly for load balancing, right? How we can achieve load balancing over here. If these all routers are up, right, all ISPs are up, then we can forward traffic of, let's say, VLAN 10 to router number 1, VLAN 20 to router number 2, or VLAN 30 to router number 3. Or we can perform load balancing on the basis of per packet also, per host also, per destination also. So by default hsrp and vrrp cannot perform load balancing. To perform load balancing in hsrp and vrrp you have to create multiple group, but in glbp we can perform load balancing. In glbp again hello time is similar like hsrp, 3 seconds. Hold on time 10 seconds. It uses port number 3222, right? Its multicast address is 224.0.0.0.100, and I think 102. Again, priority over here is by default 100, right? Preemption is by default again disable in glbp. So mainly we come up with glbp for load balancing. Okay, so in configuration we will see what are the difference. Otherwise, these all protocol purpose of these all protocols are same, to provide redundancy for default gateway. Okay guys.
Is it a Cisco proprietary protocol?
glbp na? Yes, yes. glbp and hsrp is Cisco proprietary and vrrp is open standard.
What is the difference between hot standby and cold standby?
Hot standby and
Cold standby.
again I don't know what cold standby. Okay guys. So tomorrow we will see the practical of these all protocols. Then maybe on Saturday or on Sunday I will cover access control list ACL. Any question?